Hi and welcome everyone to the new seminar. Today I'm going to talk about accelerating data analytics with RAPIDS cuDF and mostly cuDF.pandas. Everyone that heard about data analysis and data analytics must have heard about these libraries, NumPy, SciPy, Pandas, Matplotlib, and scikit-learn. But today, I'm specifically want to talk about pandas. Pandas is everywhere we look. When we want to do some coding, some simple analysis, for example, loading some CSV data or other kind of stuff, we all need pandas. It's been downloaded more than 170 millions monthly, and as you can see in this chart, it shows a slight increase in the amount of downloaded. So yeah, we use pandas every day. But pandas has some drawbacks. The thing that it is pandas is slow for large data sets. And why is that? The first reason is that Panda is single-threaded. It can do just one calculation at a time for a dataset. And it is not a query language like SQL. So it cannot see all the operations before and cannot do the optimization that some other tools can do. So it's made it to be slow. As you can see in this benchmark on the left, it's some simple query. I think it was the group by and a 5 GB dataset. As you can see here, Pandas version 1.2.5 took 70 seconds to do this operation, while other alternatives and data like cuDF we have, it only took 17 seconds. And DuckDB is 14 and Polars is 11 seconds. So yeah, Pandas is really slow. And on the right, it is a little bit small to see, but Pandas is this cyan color. And this chart is for reading the Parquet file. This purple one is Polars and the orange one is DuckDB. And you can see it in comparison how much faster they are compared to Pandas. So to make up for this gap in Pandas and in this slowness, many companies developed some frameworks to resolve this issue. We have Dask, Modin, Wax, Apache Spark, and Rapids. Today, I'm specifically going to talk about Rapids. So Rapids is an open source suite of GPU-accelerated AI libraries. It is developed by NVIDIA and it's provided with familiar Python APIs. We have cuDF, which is a GPU-accelerated and that's cuDF. We have cuML, which is CPU and GPU bounded to use some machine learning, and cuGraph, which is GPU accelerated for doing the graph analysis. If you want to know more about cuDF, my colleague Shinhei previously talked about this in our YouTube channel, so you can watch this and get more information that how will this work. So NVIDIA first developed cuDF, but cuDF has some problems that leads them to introduce cuDF.pandas. cuDF was not supported all the pandas features. Only 60% of its features was supported. It needs GPU for development and testing, and it is somehow the same for the cuDF.pandas. And cuDF required processor swapping. So if one of some part of the codes are running on the CPU and some other on the GPU, you have to write the code somehow to make this swap. But the beauty of cuDF.pandas is that you don't have to do anything. You just load the cuDF.pandas and that's it. Your code's gonna be run much faster with it. In this other benchmark on the right, you can see that it is for database-like operation on a 5 GB data set. It is for the joint query that cuDF.pandas take only 1.9 seconds, while pandas took more than 300 seconds. So yeah, this is the huge difference. And also cuDF.pandas do much better than other alternatives that we have, for example, DuckDB and Polars. This is somehow the same for the group by queries, and pandas doing better than any other alternatives that it has. So I'm gonna show you a demo and show you how it will help us to run our codes faster. For doing this on our cluster, we have to use RAPIDS. And for using this, we have to build an obtainer and get an image and do our analysis there. So in this page, in our wiki page, here it can gives you all the steps of what is Rapids and the steps of how you can run that on our clusters. So first of all, we have to get an image. For doing this, we are going to the NVIDIA website and find the image that supports cuDF.pandas. But it supported many images. The first one is the base one, which is a RAPIDS environment ready for use if you want to submit your job on the Slurm scheduler. But today I'm gonna use the runtime images, which gives me the opportunity to use the Jupyter Notebook, which I'm gonna do my demo on this. To give this, find these images, you have to go to the NVIDIA website. I put this link in the presentation so that you can find it. Here it's in the RAPIDS notebook. It gives you some information about what is RAPIDS, and I'm using the latest version of RAPIDS because the older versions do not support the cuDF.pandas. You have to go to the tags and find the one that you want. It's gives you the many CUDA versions with different Python versions. I'm using this one, which is the newest one, and with the CUDA 12 and Python 3.10, which was introduced 27th of February. To do this, as we have here, it gives us the instruction to do that. I'm gonna just go to my terminal. Before that, I have to copy this link here. And using the latest obtainer. Like I have previously downloaded, but yeah. It's gonna start building. It will take several minutes to be built. So I'm gonna show you here that this is the obtainer image that I built. So we can go on from this. The next step is asking for the allocation. So I'm gonna ask for 2 CPUs and 1 GPU. So I'm waiting for the allocation. Yeah, now I have my allocation. The next step is loading the obtainer module. And then I should launch the obtainer shell. So this --nv key is for binding the GPU to the obtainer, and -b is specifying the binding to the file systems you want to use in your obtainer. And then I'm just giving the images that I built here. Now I have to activate the conda environment in the obtainer. Okay, everything is done on the obtainer. Now I'm gonna ask for the Jupyter. Let me first show you our wiki page here in the Jupyter Hub. You can find the step-by-step instruction, how you can ask for the Jupyter and do the configurations needed. Okay, here is the URL that it gives us the location to the Jupyter Lab, but since it's on the compute node and compute node does not have the internet and does not support internet on the Graham, we have to make a terminal. So to do that, I'm just on my terminal in my local home, and what I have to do is okay, no, SSH-L, and I'm defining port 999 as my local port, and here it's on the port 1158, node 1158. And asking for. Okay, now that we forward the ports, the only thing that we have else to do is, sorry. Not sure. Let me check this token here. You have to go to the local host and the local port that you defined and pasting the token. Okay, I'm here on my notebook here, and I have the allocation, I have the GPUs, and now we can go on with our demos. First of all, this notebook and these codes are based on the NVIDIA talk. So what I'm gonna do here is, first of all, I'm gonna do some simple queries with only pandas, and then I'm gonna load the cuDF.pandas and to see how it's gonna help us to run our codes faster. The dataset that I used was parking violation dataset, but it was so huge, more than 40 gigabyte, I think. And so it took many time to be loaded. So I extract only 6 columns from it and copy it into the new CSV that I'm loading here now. So first of all, I'm loading my pandas and my datasets, and the dataset will be like this. I have the states of the US, the license type, is it personal, is it commercial, the summon number of the tickets, the violation they committed, double parking, no parking, and the street cleaning, the amount of the fine they've been charged, and the violation status. As you can see, this data set has many NaN values and it has to be clean. But I want to keep it as huge as it possible so that we can sense the difference between running the code with pandas and also with cuDF.pandas. So the results are not that much reliable. So the first line of coding is which parking violation is most commonly committed by vehicles in each state. I'm just gonna time every cell that I have here to see how much time it took. For that, I just extract the state and violation column from my dataset, counting the values and grouping it by the states. So it took 7.26 seconds. And the result is the New York with the most amount of violation, which is the speed in the school zone. The next query is which license type is mostly committed parking violation. So like before, I just group by the license type and count the values. It took 2.29 seconds. The third one is total amount of fine in each state. It also took 2.86 seconds. And the last one is which parking violation is most commonly committed by different license plates. And it all took 4.69 seconds. So we've run all of this with pandas. Now I want to load the cuDF.pandas. For that, I just have to restart my kernel first. Okay. As I told before, for using the cuDF.pandas, you have, first of all, we have to import cuDF and then just load cuDF.pandas. We do not need to change any lines of our codes, and it will be run on the cuDF.pandas. I read my CSV file again, and I'm gonna run the same codes as before. The first one that we had took more than 7 seconds, but now it only took 1.44 seconds. So it's more than 5 times better and faster. The second one took 2 seconds, and now it's only 140 milliseconds. The third one just took 80 milliseconds, so you can see, yeah, it's more than, I don't know, 20 times faster now. And the last one, I think it was 5 seconds. Now it's 600 milliseconds. So cuDF.pandas can run much faster than the regular pandas. Now let's talk about another aspect of the cuDF.pandas, which is profiling. Many of you may heard profiling in Python. Python has many different profiling libraries that can help you to see which lines of your code taking much time and help you to reduce this amount of time, make your code more efficient. For example, get rid of the loop functions and these kinds of things. cuDF.pandas also has its own profiling libraries. I here have some simple data frame. It has only 2 columns and 6 rows. For the sake of the demo only, the profiler in the cuDF is cuDF.pandas.profile. I'm gonna run it, and it gives us the information that 3 GPU functions has been called and 1 CPU function. Here, it gives us the information that the max function has been running on one time on the GPU and one time on the CPU. And the group by and the count functions that I have, they all both run on the GPU. So why is that? Why just they are max functions once run on the GPU and once on the CPU? The answer is in defining the access. If I make this access to 1, you can see that every function runs on the GPU. The cuDF.pandas cannot support the axis equal to 0 for the max and the min function. So yeah, this is some kind of a drawback that it has. I want to introduce another profiler. It's the line profile that gives you a line by line estimate of how much time it took. It's the same data frame and the same code. And yeah, here is the result. It gives you that it tells us this first line that's creating the data frame can be run on the GPU. Concact this small data frame is also GPU. But here in this loop that I have, one of them is running on the GPU and one of them is running on the CPU. And the count and group by as before is on the GPU. If I make this to the 1, you can see that everything is running on the GPU and we have no CPU time here. So let me show you something else. We have now want to talk about the count function here. Using my default data frame that I had before and just want to count the amounts based on the axis. Here, first of all, I have the axis equal to 0 and everything is running in GPU and it is what we expected from it. But if I make the axis equal to 1, it will take 30 seconds to be run because the count function, the cuDF.pandas again cannot support the count function where the axis equal to 1. Yeah, it took much longer time. Yeah, you can see that it's on the CPU and it took 28 seconds to be run, and only the GPUs that we have, it's the for loading it. Yeah. So I just here I mentioned that where you can find the obtain your images, the tag that I'm using, and how you can build this, and how to request for the allocation, and how starting rapids on a shell within the GPU, and the configuration, all the configuration, and the wiki link to running the Jupyter Notebook. So before going further, everything that I mentioned about running the obtain your images and activating and launching it will in the near future will not be used because the cuDF.pandas and every its friends gonna be on our wheelhouse. So for now, if you want to use the cuDF.pandas, you have to go through this procedure, but soon you can just load it from our wheelhouses. So here is the comparison that I made with pandas and the cuDF.pandas for the codes that we saw before. It's somehow the similar results that we saw for the first one. It's more than 70 times speed up. For the second and the third, it was more than 20 times. And for the last one, it was more than 6 times run faster. So what I've mentioned is pandas is great. Pandas, cuDF.pandas is great, can run your code faster and more efficient, but it has some drawbacks. One of them we saw before that not all the features are supported, not everything can be run on the GPU. The other thing is that cuDF.pandas is not designed for distributed or out of the core computing. So if you need to run your code on multiple nodes, you can use Desk cuDF, which gives you this opportunity to do that. And also another drawback is that the pandas cannot interface smoothly with Python CS API nowadays. So they're working on it, and maybe in the near future it's gonna be much better. But for now, it has some drawbacks and also advantages. I'm just gonna last show you the website of the Rapids and the cuDF.pandas. It's really useful page. It can gives many information as you can, how to run your codes and the benchmarkers and the frequent questions. This is the benchmark that I used here, and yeah, every procedures and every setup. You can use the cuDF on the Google Colab if you prefer, but just you have to activate the T4 GPU in it. But since it's not going to give you much of a GPU, I recommend you to use our cluster. But for doing this on the cloud, you have to install it, and this is the link to do that. And here's some codes, and this is the how it works. It's some follow chart, how it's gonna give you the result for this. And here's really good information about cuDF.pandas, compare it to another alternatives. And yeah, that's it. Yeah, thank you for your attendance here, and that was all.